Welcome to Alvin Gao channel again. Today we're going to talk about imaginary stuff. Before we dive into our topic, we made a new math sign that looks like this. So today is true that we're going to talk about So it's true that we're going to talk about imaginary stuff, and we're going to talk about imaginary bases. So remember last time when we were doing the silly interest of eye thingy, we ended up with the spiral thingy, right? So I can share my screen there. $84 more. This looks a little hard to do. I'm going to search I. No, that didn't help. Incorrect. Gee, that didn't help at all. Maybe I could just look like this. Twin dragon thingy, right? Yeah, I have a lot of graphs. Oh, finally found it. We can close these folders up. So, remember last time when we made this? Did you remember? Now when I think about this, yeah, this color looks a little bit better for that. We just came in to take a good view of it, but now we're adding a new one. So this one, I'll call it imaginary bases. Got it. So for base I, it's pretty simple. Today we are working on complex ones, and if it's just pure imaginary, well, not that simple. If it's just real, not that interesting. Yay, so we're going to start by adding a new folder called base I+1. So we are only working with integers today, so we'll explore 4 of the most common. So we'll explore 4 of them. So now we will explore these. Base I+1, base I-1. New folder. It should go over here, right? Base -I+1. Gee. I always go first, remember? No fair. Base -I-1. Okay, but now we're going to add another folder, general. So we're going to add the colors. I'll label them by C. C1, I'll call it, C1, G, equals RGB of 25500. That makes it. Now I'm going to duplicate this. This is the exact same thing. Now it's black. Now it's green. I'm going to set this to C3 equals RGB of 0, 0, 255. And C4 equals RGB 0, 0. Actually, 255, 255, 0. Actually, 127 would be better as... Actually, 255 is going to be better, even though it might be better later for the color ratios. So now we are going to start with base I plus 1 table G. So we are going to set the settings red, bright red, I1. Now we are going to turn this into a table G. X2, Y2. Nonsense. Green. And what should we call? Oh yeah, we should add this. Yeah, what should we call this? IN1. N1. Even though they have meanings, see if you can figure the meanings I assign to them out. Lines, check. So now I'm going to call this done. Finally, we are going to add another table here for that has yellow check. Better. Now, what we are going to name this is done. So now we have 4 spirals, and we also have notes to do. So we are going to call this base. Too bad I didn't do giant text title. Base base 1 plus I. They don't realize that I'm doing math right. So we're going to do some notes for this, but for the most of the time we'll focus on the Desmos thing. Remember how fun the spiral is? So we are going to share again. So we are going to share. I don't know why this never Hey, this never works, however. Yeah. Anyway, we are going to start by looking at this. We are going to do the spiral thing. So 1, 1, this is how it always starts. Actually, the first power is 1, 1. Now when we square it, there suddenly becomes no more imaginary. So wait, I'm going to label this. Graph settings. X is usually represents, oh yeah. No, let me, yeah. What does X usually, anyway, I get to make the rules because this is my graph. I'm going to make X real. Yay. So now when we square it, somehow something very weird happens. It turns into 2i. So that means that no more twice it. This is going counterclockwise. Yeah. So now when we multiply by I plus 1 again, the 2i, when it multiplies by I, it becomes -2. But when the 2i multiplies by 1, it turns into 2i. See, I guess that wasn't so good if you put it in the bank. So now we get to continue multiplying. This time we notice that -2i plus 2 times, I'll fire up a calculator. I will not do the work. I will fire a calculator. Yeah, enter a problem. -2 plus 2i. This is my problem. It's the imaginary calculator, you know. -4. Gee, this definitely isn't very good if you put it in the bank. You will owe the bank a few dollars, right? Now this is easy to multiply. I plus 1 -4 -4. Everyone knows that. Wait, I see a spiral pattern. Can't I just follow the pattern? Come on, fine. 2, 2 -4. Wait, why did I call it O? Fine, what should this be? Yeah, -8. This looks like half a heart. It doesn't quite match up though. I need a clue because I do not want to do the work. 16 -16. Gee, probably no to that. Way too far. 8. Now this looks great. Gee, you're going to get rich. So now, if we continue doing the spiral, then we get the exact same fractal. Well, at least I will call it a fractal. It's the same. Yeah, as we zoom out, we can see that it increases exponentially. So that means that it will blow up. And it does. See how it blows up so quickly? So now, when we are done playing with this is quite fun. To look at the limits, we have to go suddenly to a very big scale because we want to see 256 over here and how much money that is. Yeah, that is a lot. You're going to get rich, believe me, if you are patient enough. 0 again, minus 128. Oh no, you owe too much money if you aren't patient enough, I always say. Now you owe only imaginary money. But wait until this comes. Gee, this is quite fun. Home screen. See, we could go down into negative values, but let's explore a bit at I minus 1. Wait, I forgot. Oh yeah, X is... Gee, this doesn't look like you're going to get a lot of money. Better fire up the calculator. Hey, no fair. Wait, did I do the wrong thing? I said I minus 1. Oh. I minus 1. I minus 1 squared. Gee. Wait, when did I click the caps lock thingy? Minus 2i. Oh yeah, that's simple. They're just opposites. No wonder they call it conjugates. This is when you're going to end up at the same point. They interlock hands for once in quite a while. Gee. This doesn't look right. Minus 4, 0, 0. Got it. It goes up instead of going down this time, but it's still a fractal, remember? At least it's still what I call fractal. You win a lot of imaginary money, which will suddenly turn into how much real money you have until you have a lot, but then you have no imaginary money. Looks quite interesting, doesn't it? Now it's just the same thing again. It's what I call a fractal. It's self-similar. I mean, it's jagged forever. If you zoom in enough times, I mean, it's those self-similar fractals. Minus 32, minus 32. Cool. Now, minus 64, 0, same thing, minus 128, 128, nope, that is supposed to be 64, you know, 64, then 0 again, 128, you win a lot of money. 128, 128, 256, 0. Yeah, if we look at it from the side, it looks like a heart. Yeah, but then there's that silly little circle thingy in the middle. And if we look the other side, it also looks like a heart. So, now we've probably saw something very interesting, so let's take a little note thingy. Yeah, I know these should be next to each other. So we see that. So let's retrace the steps. First it goes up, back, down, forward. Up, back, down, forward. Makes sense. Up, back, down, forward. Yeah, what else do we know? Yeah, those are some notes. Now let's play with minus I plus 1. 1 minus 1. Wait, that's the same starting point. Minus I plus 1, I'll call this anyway. I minus 1. Okay, that was clever, was it? Gee, I guess they'll be related again. And I'm right, because I have done this before. Well, I mean, I have done work with conjugates. 2, 0. Wait, why did I put negative? Maybe I put them the wrong way. 2, 0. Then, yeah. 2, 2. Yeah, makes sense, doesn't it? 4, 0. It follows a pattern where it reflects along the very beautiful axis. I hope that's how it goes. Oh yeah. Now it comes down as loops at this point. Gee. Put the 0 the wrong place again. It's a heart. Yeah. It goes towards the left to this point. Gee, I don't think you would want to be in this bank. Over here. You owe more money. How in the world would this be true? You just get away with imaginary money. I mean 32. 32, 32. Wait, when did I put the 1? Let's zoom out. 64, 0. 64 minus 64. 0 minus 128. Minus 128. Minus 128. Minus 256. 0. This is a bank you would definitely wouldn't want. This looks a little sick. Hold for half. And the thickness probably 0.5 would. Yeah, probably I'll set this to 1. Fine. This looks a little bit better. Yeah, I would like to have more information. Hey, home screen. Do you see how there's never a point where all 3 intersect? At least I can't see a point where 3 intersect. Who knows? -1, -1. Okay, I hope that the data is exactly the same, but if it isn't, I can still fix it. That's probably enough. .5, 0.5. Yeah. Okay, what did I do? 10, 5. Yeah. Now, I don't think it will look that good. See? It doesn't look that good. I mean, if you ask a bank for this, it doesn't look that good. The Desmos does look that good. 4-0. See, it really does make quite a pattern as it reflects over. The numbers are still quite small. I set this to that. Now it looks. Yeah, how come I forgot to put minus? -16, -16, 0, -32, 32, -32, zoom out. 64, 0, 64. Yeah, wait, what's up there? Now it looks right. Wait, what's 128? See? now over here, what will we do? Wow, this does look very different long term. Negative, positive, negative, positive, negative, positive, negative, positive. Yeah, the two on the left are oscillating between negative and positive, while the two on the right are oscillating are not oscillating, but actually both of them are oscillating, but one is a negative, one is a positive. Let's look at some details. See how they form this special type of hexagon. Hexagon, and now with vertical again. And hexagon, 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 hexagon. Yeah, there's a lot of hexagons over here. As it appears that if these were connected, then it appears that the hexagon is continuously spinning as I zoom out. It looks like the hexagon is spinning. Oh. Let's see why. The reason is because it's made out of 4 spirals, and each one of the spirals connects to all the other 3 spirals closely, as if the first spiral, the second spiral, the third spiral, and the fourth spiral were the same, just reflected over lines. So these lines are the same as if just reflected, but since I repeat in groups of 4 and 4 90s makes 360, so the hexagon appears to be spinning in 90 degrees with some color changes. Yeah, the color changes aren't quite obvious. It's funny. However, as it spins, the color changes are odd. But the color changes also spin that way, so it goes counterclockwise 90 degrees. Yeah, I would like to save space. Looks beautiful, does it? So, now, let's stop. So, there's something very interesting about the 4 spirals. They are the same, basically. The numbers are the same anyway. So, if the numbers are the same, that means that it is the same. Just positive and negative. Yeah, so it means that if the numbers are just different, it's like if you go to a bank. Have you ever went to a bank before? Now we will share. This is what I'm going to share. Have you ever went to a bank before? Look, the red spiral is what will happen if the bank offers you an interest of I, while the green one is what will happen if he offers you an interest of negative I. Looks like the negative I thingy is better. is it? So, meanwhile, the blue thing will happen if we offer you a compound interest of I minus 2. The yellow one will happen if it's negative I minus 2. All together. Wait. Stop for a moment. Look, red. It looks like if it's spinning over, turning over. Yeah, I'd probably say so. But I can put them in an order so that they're turning. Yeah, this goes before that. See, red is over here. Then it flips over again, flips over. And then if it flips over one more time, it goes back to blue. Just see how beautiful this is. I will share the link in the description. Save this. Thank you for watching.